Hey, how you doing guys? It's Ilya Belly here. I do coding stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called implement trie or just prefix tree. Implement a trie with insert search and starts with methods. You can check this out and note you may assume that all inputs are consist of lowercase letters A through Z. All inputs are guaranteed to be non-empty strings. Well, as you know guys, trie is just a data structure or just like prefix tree. It's a variant of any tree, which stores like nodes, and each node can contains can contain up to 26 children. In the case when we use English alphabet, searching in tries in try takes big of k time, where k is the number of nodes. Something like similar to hashing. When we use hashing, that most people think that is constant time, but that's not entirely true. That's big of k. In the case of searching, kind of like when we got like prefix, right, and we wanna just find like if that whether that prefix matches to this kind of like if we got app, so we wanna make sure that app matches to Apple. That's it. To mark that, and to mark that path, like path down the tree, to mark that path as a complete word, we can mark the last node as we can use boolean value to mark this mode, that node as complete, to mark that path as a complete word, or we can just create an extra node and mark that node as a star. Yeah, let's start. I'll show you how to do that. First you need to create a class node. It contains character L, means letter, and boolean is word, to mark that node as a complete, as the last node into that path. Also we create an array like children, up to 26 children can contain that node, each node, and we need to initialize node, so we say node character C, this L letter equals to C, and this array equals to new node, and the size of that array will be 26. Next, what we're gonna do is that we need to create node root initial equals to null, and we say this root equals to new node equals to new node, and here we say yeah, Next, we need to implement this method insert to insert the word into the trie. So it's a node current equals to root. Next, we're looking through these characters into that word. Word dot to character array, and we get the child equals to current dot array c minus a, because we use ASCII table, like the ASCII representation, and if in the case when child equals to null, when there is no child, we need to create a new one. Child equals to new node. We pass c, the name of that node, say current dot array c minus a equals to child. At each iteration we set up the new value to current to child to get to the next child, and also to mark the path as a complete word we say current dot is word equals to true. Next, to implement search we use the same approach. Can copy and paste. There is a small difference. If child equals to null, there is no child, then we return false automatically. Otherwise we need to return the case if we found the complete word, not just a part of the word. And here here we are given just the part of the string, the part of the word, just prefix like app, right? So we just need to make sure that the prefix matches to the word. So here we just say prefix word, and here we return false. False, and we just return true if we found the word, the prefix matches the word. Yeah, that's it. One more time, we create a node, char like the name of that node, to mark this that path as a complete word. We create boolean is word. We create each node can contain up to 26 characters, English alphabet. We initialize data structure. We create a node root initial equals to null. Then we initialize a trie data structure. We insert, we say current equals to root. We are looking through these characters into that word, and to get the child we say current dot array of children, c minus a, because of the ASCII table. If there is no child, then we need to create a new one. and yeah, as you can see here. And to get to the next node, we need to say current equals to child, and finally, to mark that path as a complete word, we say current is word equals to true. Here, if we ain't found the word, then we return false. Otherwise, we just return only in the case if we found the complete word. And here we are given just the prefix, not the complete word, so we just here return true, and here we return false if there is no child. That's it. Let's run this code. There we go. Great. Success. Nice. Thank you guys for watching. Leave your comments below. I wanna know what you think. Follow me on Instagram, add me on Snapchat. Check the description for all my information. Give me a big thumbs up to support my channel. And see you next time. Have a beautiful day. Bye.